This will be another demonstration of generator synchronization. We have two three-phase AC generators here being spun by AC motors. Each motor has its own independent speed control, and currently these two generators are unsynchronized. You can see with our stroboscope here flashing a bright light at the two generator shafts. We can see that one piece of tape on the sheave appears to be rotating backwards slowly. The other piece of tape is holding its position. So these two generators are now spinning at slightly different speeds. We have them situated or connected in such a way where we can measure the phase difference between them using this bank of lights. You can see the bank of lights slowly light up and then go out, and light up and go out. When the lights go all the way out, that's when the generators are exactly in phase with each other. When the lights are at full brightness, that's when the generators are 180 degrees out of phase with each other. You're seeing the maximum voltage drop between those two generators. This one circuit breaker, or contactor if you will, is the one missing link to connecting the two generators together. Right now the breaker is open. We're measuring the voltage drop across each breaker contact with a light. So when we see bright lights, that means a big voltage drop across the contactor, and we do not want to close it in that condition. We want to wait till the lights go out and then close it. When we close it, those two generators will be locked in sync with each other. So let's go take another view of our tape on the sheaves. I'm going to have my assistant here tell me when this piece of tape comes around and is oriented in that direction. So tell me what's getting close to it, and we'll sync it up when I see the lights go off.
Alright, next one.
Okay, so now I've closed the breaker. We have now electrically coupled these two AC generators together. You can see, based on the stroboscope's effect, how these two pieces of tape are pretty much in line with each other. It's not a perfect alignment because we didn't actually try to align the tape when we laid it on the sheaves, but you can see they are staying in phase with each other. Now what I'm going to do is demonstrate what will happen when I trip the breaker. When I pop the breaker open, you'll see this start to drift again. So here we go. I'll say 1, 2, 3, then I'll trip the breaker. 1, 2, 3, trip. You can see immediately as I open up the breaker, these two generators are no longer coupled to each other, and they have the ability to drift. They are now independent generators. In the electrical power industry, we call this an island condition. Each generator is its own island. It's running without synchronization, without commonality to the other generator. And of course, to sync them up again, we have to wait for that opportune moment when the phase difference between them is 0. So, if you bear with me, what I'm going to do is wait for these lights to go dark. I'll close the breaker again, but I'm going to do so at a different position. I'm not going to wait for this tape to come around to that position. I'll do it in some other position when they happen to be in phase. For example, I'll do it right now. So here, we see a condition where the two generators are locked together. You can see that piece of tape appears to be standing still. That piece of tape appears to be standing still, but they're not exactly in phase. The reason why this works, these are multi-pole alternators. They're not two-pole machines, and so there's actually multiple positions on its rotation where these two sets of three-phase voltages could be in phase with each other. So I just happen to choose another place in the rotation of this generator shaft where in-phase operation is possible. Now, if these were two-pole machines, there would only be one position on this shaft where it could possibly sync up with that one position on the other shaft. But being that there are multiples of two poles, I have options available to me. Once again, if I trip the breaker, you'll see these start to drift out of synchronism again. 1, 2, 3, trip. And now they're no longer electrically coupled, and you can see that one drifting.